Hello there, this is an Algebra 2 video. It is Chapter 6, Section 7, and today we are going to be talking about solving radical equations and inequalities. And just so you know, this is the last section in this chapter, so a test is coming your way very, very soon. So, solving a radical equation basically involves 3 steps, but the most important of those steps is probably the first one, which is that you always want to, well, I shouldn't say always, but in general, your best bet at making or being successful at this is going to be for you to isolate the radical expression. Sometimes, just remember that sometimes those radical expressions can be explicitly radicals, where you actually see the square root or the cubed root or the fourth root and whatnot. But sometimes you can see that in a fractional or rational form. In other words, it might have parentheses to the 1/3 power or 1/2 power or 2/3 power and that kind of thing. So just remember that whether the expression is explicitly a radical or if it has the rational exponent, to remember that that expression needs to be isolated before you can carry on. That's the first step, is to isolate the radical on one side of the equation. The second part is pretty simple. When you want to get rid of a square root or any root, you want to raise it to the reciprocal power. And again, if that doesn't make sense, we'll show you right now in a second. And then the last thing, which would probably be the second most important step, is once you've actually solved for x, you definitely want to check your results, because it is possible when you have radical equations to have what we call an extraneous solution, which is a solution that you attain by doing all the right math steps, but when you plug it back into the original equation, because of the domain issues with the radicals, sometimes those solutions don't make sense or don't work. So we call those extraneous solutions, so it is possible to get those. So make sure that you check your solutions all the time when you're doing radical equations and inequalities. All right, so first step, like I said before, most important step is to isolate the radical. So here's my radical right here. So in order for me to isolate it, I'm going to subtract this 4 to the other side, which will give me the square root of x plus 2 equal to 3. Now that I've isolated the radical, now I can get rid of the radical, which is a square root. And to get rid of a square root, we can square both sides. Which, by the way, if you have this in a rational exponent form, this would be x plus 2 to the 1/2 power, and the reciprocal of 1/2 is 2. And we do that because if we had the 1/2, obviously it's clear here that you have a square root and a square and they cancel. But also, if that was written x plus 2 to the 1/2 power, then you want to raise that to the reciprocal of the fraction here, which is 2 over 1, or just 2. Because when you have a power raised to a power, you multiply the exponents, and 1/2 times 2 is 1, and anything to the 1 power is itself. So basically, in essence, it would cancel just the same. So just want to make sure that you're aware of that. And so back to what we were doing here, it's going to cancel, and you're going to get x plus 2 equals 3 squared, which is 9. You subtract 2, and we get that x equals 7. And we definitely want to check our solution just to make sure that it actually works. So we know that 7 plus 2 is 9, and the square root of 9 is 3, and 3 plus 4 is in fact 7. So in this case, the x equals 7 works. So our solution there is x equals 7. Now in part B, it's a perfect example of what I was saying earlier about you can't always isolate the radical. In this case, the reason is because you have 2 of them. And no matter what you do, you're going to end up with a radical at the end of the day. So in this case, you can't really isolate either radical. So at this point, we would in fact go ahead and square both sides to get rid of at least one of the radicals. And you're not going to get rid of both of them, at least not completely, and I'll show you why in a second. But that's going to be okay. So over here, what's going to happen, like before, there's going to cancel. So you get rid of the radical on the left. But on the right, you're not going to get rid of it. And if you do get rid of it, you've done something wrong. In other words, a lot of students sometimes will forget that this is not a squared minus b squared. This is actually a squared minus 2ab plus b squared. That when you have a binomial raised to the second power, you have this middle term. So you're right that you do get 2 squared is 4, and negative root x squared is going to cancel there, and you're going to get plus x squared like this. Sorry, not plus x squared, plus x. So in that sense, you did in fact get rid of the square root. But the problem is that you forgot the middle term. There's a minus 2ab. So we should have minus 2 times 2, which is 4, and then times root x. So I said earlier that you're not going to get rid of the square root entirely. You did get rid of this root x here. It got squared and then became just an x. But now you introduce this minus 4 root x. And that's okay. That's going to happen. But I just want you to be aware that you can't just go a squared minus b squared with the right-hand side there. So instead, we end up with 4 minus 4 root x plus x. But we can still solve this because now we can try to get all of our variables on the same side. So now we do actually want to do what we said earlier, which is to try and isolate the square root part. So I'm going to subtract x from both sides, and lo and behold, yay for me, x minus x cancels there, you get negative 12. And over here also cancels, x minus x cancels there as well. So now we don't have that x term at all. So we get 4 minus 4 root x. And then we want to bring this 4 to the other side. And so now you get negative 16 equals negative 4 root x. And of course, now we can divide by negative 4. And dividing by negative 4 on both sides is going to give us positive root x on the right. And negative 16 divided by negative is positive 4. And now we can square both sides. And we get that x is actually equal to 16. But again, we want to make sure that this solution actually works. So on the left, from the original problem, we're going to get 16 minus 12, which is 4, and the square root of 4 is 2. So on the left, we get 2. On the right, we get 2 minus the square root of x, or 2 minus the square root of 16, and 2 minus the square root of 16 is 4, so you get 2 minus 4, and 2 minus 4 is negative 2. So you see, positive 2 does not equal negative 2. So basically, we have no solution for this case because our answer did not work in the end. It was an extraneous solution. So we have no solution for part B. So again, you can do all the math right and you can get an answer that doesn't quite work. So please, please, please make sure that you check your solutions all the time in this lesson. And of course, be careful with 2 and negative 2. A lot of times we kind of forget that there's a negative there. And we're like, oh, 2 and 2, so they must be the same. No, a 2 and a negative 2 are not the same. So no solution for part B. So now we're going to have you try this example. And then we're going to move on to more examples. Okay, in example 2, you can see what we were talking about earlier, where there's no actual radical, there's no house, but we do see the fractional exponent here, which is pretty much the same thing. And just like in the previous example, our goal is to isolate that part of the expression. So in order to do that, we're going to add 4 to both sides. It's important that when you do this, that you always deal with addition and subtraction first, and then multiplication or division. So in other words, I'm not going to divide by 2 first, I'm going to add the 4 first. And that's going to give me 2 times 6x minus 3 to the 1/3 power equals 4. But I still have this 2 in front. And so now I do in fact want to divide both sides by 2 to get rid of that. And that'll leave me with 6x minus 3 to the 1/3 equals 4 divided by 2 is 2. So again, that is what's meant by isolating the radical expression, whether it actually has a house or whether it's a rational exponent. We want to isolate that portion of it. And then, as I said before, you want to raise both sides to the reciprocal power. So the reciprocal of 1/3 is 3 over 1, or just 3. 2 cubed is 8. In this case, 1/3 times 3 is 1, so they kind of cancel there. And you get 6x minus 3. And now we can actually solve this fairly normally. we get 6x equals 11 divided by 6, and so x equals 11 over 6. But again, we want to make sure that we check our solution. So I am going to check over here, 6 times 11 over 6 is 11. So basically you have 6 times 11 over 6, because here we have 6x minus 3. Just trying to plug this all in here. Question is whether or not this equals 0. So the nice thing about having 11 over 6 is that these 6 are going to cancel. So you get 11 minus 3. And 11 minus 3 is going to be 8. And then we have 8 to the 1/3 power, which we know is 2. And if you don't, you can use your calculator. And then that's times 2 minus 4. So you get 4 minus 4, which is in fact 0. So sure enough, 11 over 6 is our solution. But don't always assume it's going to work out, okay? Make sure that you check your solutions. So now we want you to try do-it-yourself number 2. And then we are going to go on to our next example before we hit inequalities. All right, what is the solution of 3 times the 4th root of 2n plus 6 minus 6 equals 0? So again, our goal is to isolate the radical expression first. And I just said earlier that you want to begin doing that by dealing with any addition or subtraction first. When I say addition or subtraction, I mean any addition or subtraction that is outside of the actual radical. So I don't want to subtract 6 because that's inside the radical. But I do want to get rid of this negative 6 first. So we're going to go ahead and add the 6. So we get 3 times the 4th root of 2n plus 6 equals 6. Then we're going to divide by 3. And we have the 4th root of 2n plus 6 equals 6 divided by 3 is 2. And now, because we have a 4th root, we want to raise it to the 4th power. And remember that a 4th root is like 1 over 4. So the reciprocal of 1 over 4 is 4 over 1. So we get that. They're going to cancel. We get 2n plus 6 equals 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So 2 to the 4th power is 16. Subtract 6, we're going to get 10. So 2n equals 10. Divide that by dose. And n is going to equal 5. All right, so n equals 5. I want to show that actually works. So when we plug it back in, 2 times 5 is 10. And 10 plus 6 is 16. The 4th root of 16 is 2. 2 times 3 is 6. And 6 minus 6 is 0. So it works. So that is actually my solution. And n equals 5. So now you can try this little guy. And then we're going to go to our last example. And the lesson was called How to Solve Radical Equations and Inequalities. So our last example is going to demonstrate how to do that with an inequality. So the only difference that we have here is that we don't have an equal sign. We have an inequality symbol. This is less than or equal to. So the first thing I will tell you that you have to do is deal with domain. So basically, anytime that your radical has an even index, a square root, a 4th root, a 6th root, anytime it has an even index, you have to make sure that it stays non-negative. It cannot be negative because it can be 0, it can be positive. So before we even get started with actually solving it, we have to do a little side note over here. We have to determine how this problem will stay positive. So in this particular case, it means to take the radicand and determine when it will stay greater than or equal to 0. So in this case, we're going to add the 10 to the other side, divide by 5. So x has to be greater than or equal to 2. Already, before we've even solved for x here, the domain is going to restrict us to leaving or only allowing x's to be greater than or equal to 2. All right, so that's part of our solution, even though we haven't really gotten started with this actual equation over here at all. All we've dealt with is the domain. In order for this domain to work, it has to be x greater than or equal to 2. That's the first part. Anytime you have an even index, okay, so in this case, the square root of 4 through the 6th root, any even index, you have to do this part first. Once you've done that, now we're going to solve the rest of it like we normally would. So we're going to go ahead and do this subtraction first. So now we're going to have the square root of 5x minus 10 less than or equal to 8 minus 3 is 5. And because it's a square root, that's basically to the 1/2 power. So the reciprocal of 1/2 is 2 over 1, so squared. So we have, they're going to cancel, so we're going to get 5x minus 10 less than or equal to 5 squared is 25. Add 10 to both sides. So far nothing too different. We have to deal with the domain, that's a little different. But as far as solving this part, it's pretty much the same thing up until the very end. So at this point, we get that x is less than or equal to 7. So far, we know that our x values have to be greater than or equal to 2, but at the same time, according to this, less than or equal to 7. And then just to be sure, we have to do basically test. And that's the last part of dealing with an inequality that's different. The two main things that are different about solving an inequality as opposed to solving an equation is the domain issue, this first portion here, and then what I'm about to do right now, which is testing, okay? I basically have that my answer lies between 2 and 7. So what you want to do is basically take your number line, and there's a 2 on it, and there's a 7 on it, and that basically divides your number line into 3 regions. The numbers that come before 2, the numbers between 2 and 7, and the numbers that come after 7. And so what you have to do to make sure that your answer is correct is to pick a number that represents each of those sections. So like in this case, for example, something between 2 and 7 could be 3. Something bigger than 7 could be 8. Also, it could be 105, but why would you want to plug in such a large number? So try to pick the smallest number that you can that's within that region. A number that's smaller than 2 would be 0. Also, you could pick 1. I picked 0 because 0 is oftentimes a very easy number to plug in. Okay? So then we're going to check that our solutions actually work, because sometimes it doesn't. Okay? So in this case, if I plug in a 0 into my original equation, 5 times 0 is 5. 5 times 0 is 0. And 0 minus 10 is negative 5. But you can't take the square root of a negative number. So clearly, this solution is not going to work. If I use a 3, then I'm going to go 5 times 3 is 15. And 15 minus 10 is 5. So you have the square root of 5 plus 3. And the square root of 5 is, the square root of 5 is 2.23. So if I add 3 to that, it's 5.23, and 5.23 is less than 8. So that works. If I try to use 8, then I get 5 times 8 is 40, and 40 minus 10 is going to be 30, and the square root of 30 is 5.47, and then I add 3 to that. Now I'm at 8.47, but that is larger than 8, not less than or equal to 8. So therefore, these don't work. And so my true solution does in fact lie between 2 and 7. So my final answer is right here. I've confirmed it now by checking my results. So it's very important that you use test values at the end of the problem, because sometimes you'll be surprised that you can actually end up with the wrong interval for your solution. So just be careful with that. So now we'll give you this last inequality to do as part of this do-it-yourself question. And once you have completed this do-it-yourself question, you will have completed your notes for this lesson. And I will see you in class. And thank you for watching.